Welcome to the pre-calculus notes for Law of Sines section 6.1. Go ahead and write your title, your first and last name, and what period you're in. So the Law of Sines looks like this, and you should recognize this from geometry and algebra 2. So we're going to review what you've already learned about it and then take it to the next level for pre-calculus. So the Law of Sines basically says that the side is the ratio to the sine of the angle, and you can set all three equal to each other. But when you make a proportion, you only need two ratios to solve it. Okay, so you will see what information you're given versus what information they want you to solve for, and then you'll just pick the two that are being used. Okay, so side A over the sine of angle A is equal to side B over the sine of angle B, and side C is equal to the side C over the sine of angle C. Okay, it can also be flipped. All right. So what makes it pre-calculus level is when you have heights drawn in. So you have a height 1 drawn in here, height 2 drawn in here. So with height 1, your sine of A is going to be equal to the height 1 over side B. And if you're looking at the sine of angle B, it's going to be height 1 over side A. Okay. If you do the cross product on these and then multiply, you're going to get back to that law of sines. Okay. And here's the same information, but using height 2. So depending on which height you're given is the one you would use. But it's really the same. It's just your turned triangle. Okay. All right, let's look at our first example. So you're given that the measure of angle A is 98, the measure of angle B is 43, and side C is 22. And if you're going to solve this whole triangle, you've got the two angles here, so subtract those from 180, and that's going to tell you that angle C is 39. All right, so you have all the information on this triangle except for side A and side B. You have both angle C and side C. So I'm going to write that in the middle and use that with both of my ratios to make proportions. So the green proportion is going to be side A over the sine of angle A. Set it equal to the side C over the sine of angle C. Do the cross product, type in the calculator, and then hit the equal sign. Okay. In the pink rectangle, we're going to do C again, but this time we're going to put side B over the sine of angle B. Again, cross product here. Divide both sides by the sine of 39, punch in the calculator, and you're going to get 23.8. Okay. All right, so the next thing we're going to talk about is this thing called the ambiguous case. So the first thing I want you to do for the ambiguous case is to look at this little chart. So in the previous example, you were given two angles and one side, but what if you're given two sides and one opposite angle? So when that happens, you're going to have something called the ambiguous case, and there are three different outcomes that you could have. Either there could be no possible triangle, one possible triangle, or two possible triangles. Okay, so pause the video and copy down these possible scenarios here, and it has to do with when it's acute or when it's obtuse. So it's going to tell you each problem what the case is. Okay? All right, so the first one we're going to look at is with an acute. Angle A is going to be acute, so we're going to label the information that they give us. So angle A is 42, side A is 3, and side B is 5. Okay, so we want to know if A is less than H. So A is 3, and the H is 3.35, and we'll talk about in a second how to get that. And that's less than 3 is less than 3.5, so it does not make a triangle. So to get that h, we're just going to use that formula we saw on the second slide, which says that the sine of angle 42 is equal to height 1 over side B, which is 5. Do the cross product, solve for h, and you get 3.5 or 3.35. All right. So this one is also acute. We're going to label A60, angle A60, side A 4 rad 3, and side B is 8. Okay. So the height is the same as side A, which is 4 rad 3. And we're going to say that if A is equal to H, then you will end up having one triangle. All right, so let's look at this angle, or this example on the left. A is still acute, so angle A is 35, side A is 12, and side B is 8. Just so happens that A is greater than B, and angle B is also acute, so it makes one triangle. All right, the example on the right, we have angle A is 20.5 degrees, side A is 12, and side B over here is 31. Okay, so the A, which is 12, is between B, or A is less than B, but greater than H. So this one is going to have two triangles because A is less than B. So that means that angle B could be obtuse, or angle B could be acute. All right. So if H, that height right there, to get the height of it, we've used 31 times the sine of 20.5, got 10.6. So that is less than 12. That means that once you calculate that out, that's how you get that. Okay, so from here, there are two cases. So case 1 is the inverse sine of 31 times the sine of 20.5 divided by 12. That means that it's 64.8 degrees. And so we know which angle. We know the 20.5. So we start with 180, total degrees in a triangle, subtract the 20.5, subtract the 64.8 that we have right here, and we get 94.7. Okay, so that means that C, side C, we want to see what that could possibly be. So C over the sine of 94.7 equal to the 12 that we know over the sine of 20.5. Do the cross product. That means that C could be 34.2. Or the other case could be 180 minus 64.8, making that other angle 115.2. And so now we're going to switch that angle, and we're going to have C over the sine of 44.3 equal to 12 times the sine of 20.5. Do the cross product again, and in this case, case number 2, we could have side C be equal to 23.9 units. All right. All right, so on the little chart I had you copy down, now we're going to look at one that is obtuse. Okay, so when it's obtuse, on the left here, angle A is 108, side A is 12, side B is 16. So A, in this case, is less than or equal to B. So that means that there will be no triangles in this case. Just get that off the chart. This one on the right, or this example on the right, angle A is 112 degrees, side A is 22, side B over here is 14. In this case, A is greater than B. That means angle B is going to be acute. Let me move that over. missing? No. There we go. Yeah, I couldn't see it there. Okay, so that means we're going to have one triangle. So we're going to take the sine of B over its opposite side, 14, and the sine of angle A, 112, over the opposite side, 22. And then we're going to do the cross product here. That means we actually have to take the inverse sine of 14 sine over 112 divided by 22, and we should get 36.2 degrees. Subtract the two angles that we know, so start with 180, subtract the 112 that they gave us, subtract the 36.2 that we just solved. That leaves us with 31.8. And then we only have one side left, side C, so we're going to say side C over angle C, the sine of angle C, equal to side A, which is 22, over the sine of angle A, which is 112. Do the cross product and solve. If you need help putting this in your calculator, please let me know, and I can help you either after a Zoom or during class.